So no doubts, last class.
No doubts, no doubts.
So now see that now before doing the normalization hands-on, there is a normalization concept. So before normalization, just recap last class, we done a correlation, right? Mean, median, and aggregation functions. So renaming the columns, altering the columns, removing the columns, null value, removing that. Okay, we replaced with the minimum values. We done a lot of hands-on of the right aggregation functions, statistical level, statistics, some group by, right? We done a lot of things hands-on. So which is all using for the data cleaning, right? Data extraction, and this is all a part of the feature engineering, right? So here mainly normalization also one of the techniques which is also using for the right feature engineering. But these are all depend. Not every time we will not apply that. But see that now here two types of normalization is one is the min-max normalization, and second one is Z-score normalization. So these two are the normalization. So when we'll use the min-max normalization, Z-score normalization. So the purpose of min-max normalization, Z-score is same. But most of the times we are using the min-max normalization, right? So here the purpose to apply that to normalize the numerical features. So you know in SQL maybe you know SQL guy. So what is the meaning of normalization in RDBMS concept?
Normalization is to cut down the duplicates and all that, and
Yeah,
minimize the return.
exactly. We'll minimize that. We'll make there some partitions. So normalization will do that. So here also you think about that. Not you're not going to normalize that entire table. We are going to normalize the specific features, right? Right. That features we can make it. What features I can select to make a normalization, right? Suppose you can use that right here. Example, first one, min max normalization. See that min max normalization. Here min value means 0 and max is a 1. So the process bring the feature right in the range between the 0, 1. Whatever feature is selected for the normalization, that future values you want to take into between the 0 to 1 value. So min, maximum. So first it calculate the minimum and maximum value of each numerical feature. So after it apply the following the transformation on each value of the feature. So whatever your feature selected that, right, once that feature you apply to take the right min maximum value for the particular feature value, then we can take that, right? But that should be compulsory between the 0 to 1. Now here tell me here everything what x new equal to. Suppose you take in the 10, 25 value. Yes, you find the what is the min maximum normalization of the particular feature, right? So this because of taking the features instead of taking the long length of integers, instead of taking the long length of long variable or right big data values. So if you take that future values in between 0 to 1, and it is a good performance for your model. So that is the reason we can apply the min-max normalization whenever you want to apply for the particular feature. You can apply for the min-max normalization feature or normalization for the every value of the specific feature. Okay.
Okay.
You know point?
Yeah.
Now can you open that hands-on one?
Okay, it's open.
Right. This for this normalization, the special packages we are using there, right? skitlearn. The skitlearn we discussed till now. What are the machine learning Python packages we discussed? Pandas, numerical Python, matplotlib, isn't it? And one more library is the skitlearn. You can see there. It open my hands-on exercise file. Then you can see the first from import skitlearn is right sklearn. So sklearn is nothing but skitlearn is one of the package of machine learning library which is inbuilt in the Python. So that package you are importing, right, for the normalization.
Okay.
That's why before starting any model, we'll do that. We'll import all the whatever required packages you wanted. Then we'll start to write the code.
Okay.
Now see that now what is the value?
Yeah, one Satya.
Sorry.
Just to give me it.
Okay.
Okay, yeah, let's go ahead.
Yeah. Do the answer normalization?
Yeah, I want to understand what is the scaling actually. What exactly it does?
When numerical values, whatever the categorical values, which is high dimension reading, high dimension are there, right? Suppose there is a values with the 5 values, 5 integers, like 10 zeros, maybe 1, 2, 3, 4, 5, like this lengthy long integers are there. So then you can maximize between to the 0 to 1 only, right? So that future value you can take to 0 to 1. So here what I'm saying that you see that if you take the any future, can you see my screen? There is a formula here.
Yeah.
For the future, first calculate the minimum. For the future, take the maximal. First, once you find here, what is the min value I told you? 0. And what is the max value? 1. Isn't it? So you take the whatever the future you want to take that, xi of whatever you future value is there. Suppose the id value 1 to 3 minus, right? Minus min of x, that is 0. Then max of x 1 minus 1 to 3. Right? For this calculation, whatever the x you got it, that value you can put into in the place of 1 to 3. Right?
Oh, okay.
Like this, especially if you have a salary column. Yes, salary values are very big, isn't it? Right? Salary value 10,000, 40,000, like the different more than 5 integers values are there. So in that time, we can make it min max normalization, right? When it is it is taking the performance defect for that with a high range of values, right? For trying the model, you can take the min max normalization for every feature. Because of this, so model can take the more performance, model give the good accuracy of the your predictions. Got it now?
Okay, yeah.
That is the reason we are going to use that. That's why I told you clearly. In the range of min is 0, max is 1. Okay?
Okay, yeah.
You can take the calculator in your laptop and whatever the output you got it, that value is correct or not, according to the calculation, you can check it.
I have any more.
1 minute, let me just do it.
That's right to me.
No, you please go.
So when you're coming to India?
Maybe next year. Yeah. So, Satya, can you share that PPT with me? I mean, I want to look at the formula again.
Okay. The PPT already said you, okay, no problem.
No, can you go? Can you go out? Go.
Yes. See,
go
sir.
Out. Yeah. Okay. Okay, 1 minute.
It will give the approximated value. It is between the 0 to 1.
So
it's
like xi minus min of x divided by max of x minus
all these formulas should remember.
Okay, let me just try one value. Okay.
Okay.
Yeah, so price, let me 492.
Last
So
class we applied some
492.
formulas. We applied last class correlation and the standard deviation. Right now again this one. So all these formulas I guess send you already the PDF slide in the start of the classes. Right, statistical and the mathematical essential PDF.
Right. 41 minus 3.
So next again, who chief minister will be same person again next time because CPM.
Oh yes, a CPM. Who cares about CPM, man? I don't care about what happens to Kerala. You know.
What man, you don't like?
Yeah, but I'm sure. But no, actually I was not raised in Kerala. I was raised in
But I'm
Gujarat.
very big. I'm big
from
fan
Gujarat.
of the Kerala chief minister.
Yeah. So that's a CPM. It's always CPM Gujarat. Congress CPM. So last year it was CPM. So this year it would be Congress. You know, there's no doubt about it.
But this
But
guy
I'm pretty sure about India.
This guy is very intelligent, right? This guy, what is the president of chief minister of Kerala guy? What is the name? I forgot it.
Pinarayi Vijayan.
Yeah. Vision is okay.
Yeah, Pinarayi. Yeah, all these guys are like, politicians are politicians.
I
Right,
know,
man?
correct. But India, again, Modi, I think, I think Modi will be president.
Of course, yes. Who else can beat Modi? But I'm very surprised that Chandrababu Naidu is now with,
Congress.
Yeah, very, very surprising. How can that guy do that? I'm not very sure
Now
about
he's
it. Okay,
against
yeah, I got it. Yeah, I'm getting it right.
No, now he's against to Modi, right? Because he's all the
Yeah.
Chandrababu son he's very innocent fellow. He's in Andhra, people are calling Chandrababu son is a Pappu. Pappu guy.
Oh man.
Like how Rahul Gandhi is a Pappu, here also in Andhra,
Yeah.
Chandrababu son is. But this guy is very intelligent, Jagannath Reddy. Oh, he's how long? I think definitely he'll be the chief minister of Andhra Pradesh for coming elections.
Oh, really?
Yeah, no doubt. No doubt he will be chief minister.
Oh, okay, man. All right. Hey, so by the way, I'm getting got these values, huh?
Okay. Yeah. Now see that now. Suppose if you get that when you're doing that, you got the min maximize relation. If you get the range of between the 0 to 1, if you get the more than that value, right? You can take that Z-score normalization. Right, whatever you feature selected to take the in between 0 to 1, if any future value giving that more than one value, you can take that Z-score normalization. So Z-score normalization, which is using to eliminate the outlier of your future values. Because machine learning saying that when data is in between 0 to 1, it is a high performance of the model, right? So obviously, if you get that your value, when you're doing the min-max normalization, if you get the more than 1, you can use the Z-score normalization, right? So here, when data contains outlier, so outlier is one of the very biggest problem in the data reading. So when your value of the future is greater than 1, so that outlier we can eliminate with the Z-score normalization. Okay. Now you see again. Hello?
Yeah, hello? I'm listening. Go ahead.
So here the principle of statistics, move the data to mean 0 and the standard deviation is a 1. Now see that now when I want to take the Z-score normalization, x minus mean of x by standard deviation of x. Isn't it? You take the standard x minus mean of x by standard deviation of x. So this is the formula of the Z-score normalization.
Okay, here small x is the value, and what is the capital X?
Capital X, whatever the future you are taking the mean value of x.
Oh, you do.
You will do the first. If you want Z-score now, you should mean do the x value. you should do the standard deviation, then you can take the z-score normalization.
Oh,
See,
okay, okay. So
did you
first we
observe that when you're doing hands-on, you're not writing any big programming for this formulas, because these formulas already inbuilt in the Python library. Just we need to use the simple keywords in the when you're doing hands-on. Even when you're doing that, your min-max normalization, what you done, you didn't write any lengthy of the program. You just apply that.
Hey Satya, today the audio is not very clear from your end, you know. You keep breaking actually.
Okay, today I'm using mobile hotspot, right? Because today I came to here this place, other place. Yeah, can you hear me now?
Oh.
No problem. When voice is breaking, if any word is missing, let me know. I'll repeat it for you again. Don't worry.
Okay, all right. Yeah, let me just try this formula once, okay?
Yeah, please. So please note down all these problems for formulas. It is very important. Last class formulas, this class formulas, revise it and remember the formulas, right?
Yeah. So, what is that? 429. Okay, so the mean is by mean means you mean average, right? Average is mean,
Exactly.
right? Okay. And standard deviation is okay. So, and the formula says, 1 minute, the formula says, can you go back to the formula again?
Okay.
I want to see the formula. Z equal to x minus mean x divided by standard deviation of x. Okay, all right. Give me a minute. So 492 minus mean divided by standard 0.33, 0.35. Yeah, I got it. Okay, cool. I got this answer.
Very good. So you see that the syntax,
So
what
I'm
you applying
getting the same.
here. So this correlation, min-max normalization, z-score normalization, right, mean, standard deviation, these are the very important formulas for the data cleaning. Now you see that line number 46, right? The data frame which I created, the price frame, right? You observe here what I'm doing here, right? Min-max normalizer, the object I created, right? Once I apply the object min-max normalization, right, that object I'm going to use that, right, again z-score
Yeah.
normalization, because where min-max normalization my value is maybe is more than 1, to make it again to 0 to 1, here I'm using that object of the min-max normalization. Again here price fair normalized equal to, and column is a price, that value now price frame normalized it. Now you can see the values of the price which I minimized it, because 492, 286 is very lengthy. It is high scaled values. It is a high outlier values. So then I take in again to the z-score normalization. The price came between the 0 to 1, right?
Okay.
0 point. When
Yeah,
you
got it.
you can test yourself also without normalization. What is the performance with normalization? What performance you got it? It is very good for practice when you're doing POCs. Okay. So obviously, when you're doing the real-time development, definitely you can take one decision instead of multiple testings. Okay.
Okay.
Right. These are the very important min normalization. Right.
Okay, got it. Got it. Yeah.
Now leave it 47. 48, you see that.
Straight to 48. Okay.
This encoders very important. We have a encoders we are doing in machine learning model. In offline, we are doing encoders. When you using encoders in online, is the auto encoders. Like especially in e-commerce application recommendations, right? They are using the auto encoders. So when you're doing the offline processing on your data, we can use normal encoders. Okay. Now let's discuss encoder. What is encoder? Right? You observe here. Here also encoder belongs to the package of the sklen. So here, don't confuse. I'm telling you, yes, skitlen nothing but sklen. sklen is a package which is supporting for all normalizations, all these encoders. So this is very important in artificial intelligence. Most of the people using this skitlen, that means sklen. So you see that here, I'm creating first object encoder, right? So label encoder. So here, what I'm doing that I'm taking the categorical values to numerical, right? Categorical value to numerical, because I want to take that. So right, categorical value, what is that? Numerical value. But my question here, example, there is a gender field is there. Gender is the male value, is the female is there. So when gender male is 1, female is 0, if you take like that is okay. But example, you take the city value. The cities are many cities, maybe 100 city values are there. But I can't take the 0, 1 because Hyderabad is 0, Bangalore 1. But what about Pune? Isn't it? I can't take again 0 for the Pune.
Yeah.
I can't take the 1 for again Cochin, isn't it? Like this, obviously, when you face these type of problems, then you need to go for this encoders. Did you get my point?
Yeah.
Even employee names. Employee names are so many employee names are there. Rama, Venkat, Lakshman, Srinivas, Sajit, Sujit. There is so many people out there. I can't take 0 once for every person. So when you take this type of features to change to numerical, right, you can use this encoder to give the different value for the, right, for the future, isn't it? So example here, Delhi, Pune, Mumbai, right, Delhi. Now you see that here, encoder, which is inbuilt to Python library, is a Python function, machine learning function, which is using to, especially to use the categorical value to numerical value. Now see that now, it is little tricky to understand. Now example, when I create that encoder, it's showing that 0, 2, 1, comma 0. So what you observe here, Delhi is a 0, Pune is a 2, 1 is a Mumbai, again Delhi again 0, right?
Yeah.
This is expecting.
Okay.
But here, now if you encode like this, now you can, it is assigned automatically different unique value for the every city. But if you do the inverse, right? Now see that now inverse here I mentioned that 2, 1, 1, comma 0. Here what is the 1 here? Mumbai. Now I came the 1, comma 1, I got the Mumbai. And what is the 2 is exactly? 2 is the Pune, right? Got it. And 0 is what? Is Delhi. So I can take like this also, right? Understand? Now I'm taking here 0, 2, 1, comma 0. Even this is not my perfect way to encoding that. But I want to take that value 0 to 1 only. Now again here 2 is the extra. So 2 is I can't take the Pune, isn't it? Suppose my question, no, I don't have another option. Even 2 I need to Pune. Then what we will do that? There's no other option. So definitely you can go for the encoder. Clear now?
Yeah.
Now coming to the here. You have a already data frame. The data frame you already created. The age is data frame with you. In your data frame, age field is there.
Okay. Let me second. Hold on.
The first, I think one of the data set we created data frame for the age column.
Yeah. 28, 27, 31. Yeah, correct. Got it.
Okay.
Oh, so automatically categorizing it, huh? Less than 20.
Exactly. Here, category wise, right? Department like CSC department, EC, IT, like this. Like the category wise that, right? Pattern. So less
Yeah.
than 20 years, 20 to 40 years, 40 to 60 years, 60 plus years. You clear my point?
Yeah, got it. Yeah.
This is very important because now you are reducing a lot of scalability future values and you're reducing a lot of dimension of futures because of taking the data like this with encoder. It is highly performance. So these encoders, you can ask the question, this encoders only using for, right, not only using for offline, even I mean in online also, real time also, it will use that. Okay, understand?
Okay.
Example, there is Amazon.com visiting by, right, above 10 years, maybe above 8 years, people visiting the website on specific products, right? When that type of, because the person who is buying the product in Amazon or right, Flipkart, the person has account definitely, isn't it? Definitely is there, his details are there. Got it now? They can categorize that, which product is buying the category wise, if they want to product, if they want to give the recommendations. So this type of encoders will be very useful for that when they're training the data, when they're cleaning the data, right? Not only for recommendation, even our responsibility to take the data into 0-1 machine learning, saying like that, isn't it? Hello? Hello?
Yeah, I'm there. Yeah.
Are you there? Okay. I thought you disconnected. Now date. Here we're importing pandas. Start date, end date. Dates, panda, data frame, start range, end date. So whatever the range you given that between the 6th, 7th month, right, to the 12th month, 18th date.
Oh, okay.
So whenever you want to take the data for the specific feature, right, you can take that like this. All right.
Okay, got it. Yeah.
So I'm telling you, whatever you done this hands-on, which is the last 2.5 years, what I am doing regularly in data cleaning, data extraction, statistic, these are the very common we are using in my projects. Okay, that's why again and again telling you, you can practice many times this one. It is very useful for you, this example exercise. Okay.
Okay.
Now coming to the algorithms. Just recap algorithm last class what I explained you, right? Supervised learning, unsupervised learning, right? The supervised learning is which has label data and which has output label, out label also there. So when input label, output label is there, then supervised learning. So first we'll do hands-on, right? Supervised learning. So the model is saying that when supervised learning saying that, right, to classify the data, right, to predict the data, to predict the integer values, that means to predict the car price, to predict the stock market price. So I given the list of supervised learning algorithms. One is classification, regression. Again, regression is a linear regression, multiple regression, isn't it? Decision tree, random forest. This is all the part of the supervised learning, which is supporting when you have input label, when you have a output label. This supervised learning is also called human supervision because you are giving the data to the machine and machine training itself, isn't it? That's why supervised learning is also called human supervision. Got it now?
Right. Yeah.
In this human supervised only, supervised learning, unsupervised learning, right? Reinforcement. So these three are, right, machine learning algorithm models types are there. When data is ready, Then we'll train the data model. Okay, now coming to the hands-on, please open that.
You mean to say the Python project, right?
The algorithm first. Can you open the classification?
Yeah, 1 minute. Huh? Oh, we are done with the. Oh, wow. Okay, great.
Where
yeah,
are
1
you?
minute. Huh?
Mm-hmm. I done. I think you're thinking about Raja. Somebody.
No. Hey, did you send me that file? The only one I got is machine learning, deep learning data set. This is the file you sent me.
I sent you this exercise also. Supervised learning. I mean classification.
1 minute. Hold on.
Check it. If you don't, if not there, I'll send you again.
Yeah, 1 minute. Huh? Oh, okay. Here there are many files are there. This is the one, right? Air passenger and all that.
No, that is data sets. Which is the file which is .py.
Okay, give me a minute.
.ipynb. Like you opened, right? Future engineering file, same like that file only. .ipynb.
Yeah, but in that.
It is not there.
Directory there was a 1 minute. Let me see.
Not there. I'll share you. I'll send it again to you.
No, I don't have it. You know, I only got. Can you send me again?
Okay. Yes, I sent you, Ajay.
Okay. Right. Yeah, I'm waiting for that to come. Oh yeah. Yeah. Okay. So now let me search. It would be the same subject, right?
No. Come on, please come to the subject. What is the data scientist, the steps he's following that when he is going to deploy the model, before deploying the model into the server, what he is going to do that?
Yeah.
You recap the last starting classes. Define the problem, understand the problem.
No.
Yeah.
No, what I'm saying is, these two files, if you had sent me in the past, they would have the same subject or not? I mean, the email subject.
No. Maybe different one. Maybe I don't know. I sent you in the starting of the classes only once. First class after first class completed, then only I sent you all to email, Ajit.
No problem.
Okay. Now, yeah, you can check later. Then, yeah. So please open the first one.
I'm opening it now. Okay, so I have it ML hands-on. Okay, classification. Let me open this file in Python. Okay.
Jupyter, yeah.
Classification. Okay.
Supervised learning.
It's opening. Yeah, it's open.
So can you tell me, last we discussed that example of classification. Classification of the emails, right? Classification of the spam emails or not spam, isn't it? So when you dealing with your target variable is categorical, then you can go for most of the times using classification, right? Like to pass the exam or not, yes or not, spam or not, good or not, isn't it? Good or bad. So when you take in the your production target variable, that means which is a dependent variable, isn't it? Is categorical. Not only remember, not only don't focus which is the target variable is categorical, then I'll go for classification. So you need to understand the problem also, right? So your classification is most of the times which is dealing with the target variables which are the categorical, right? Regression which is dealing in the most of the times when target variable is the integer. Okay, first classification algorithm I want to apply. I mean, I need to train the model with classification model on my data set, on my cleaned data set. I told you before modeling, before trying the model, right, with your required input data set, you will apply the cleaning and statistics, right? You'll do extraction, future engineering, isn't it? We'll do a lot of process, what we done last class before train the model. Now you observe the first line number 1. You see that now whatever the packages you wanted, all the packages imported. You remember pandas, numpy, sklearn, matplotlib, isn't it? Now you see that now you're all supervised learning, unsupervised learnings, which are inbuilt in this package sklearn, because all the predefined APIs in this sklearn, right? Whenever you doing the supervising, these are the very common packages we are importing to the your library. Got it now? sklearn. Yeah. So you don't need to remember, just right. You can just copy paste all these packages, but check it, very important, these 4 packages which I imported. If not pandas, I can't create data frame. I can't do extraction, right? If you don't have a numpy, I can't do any numerical Python. I can't do any arrays, use it, isn't it? Now sklearn, you remember, I can't do any normalization without sklearn. I can't do encoder without sklearn. And you see the seaborn, which is seaborn is using for visualization, right? Visualization, I told you, in terms of bar, pies, charts, whatever, you can do that. What is use of visualization? To understand the data is cleaning properly and data quality is good, or data dimension is going highly or down. To understand that, visualization is very important. Now, please run your all these libraries. Click on run. Okay.
Okay, I need to install these. I think I don't have Seaborn installed. Don't I have to install this?
Did you get any error?
No, let me run it.
Because when you install Jupyter, Python automatically all these libraries will available.
Yeah, it's giving error. It gave me error for scikit-plot.
Yeah, please, you see my screen, that one, please put the comment. That means Ash, you can put it. It will skip that only and it will execute the remaining.
Okay. Yeah, it executed, yeah.
Now you see the next line, if any warnings, I don't want interruption of my model training, we can use the warning package also. You can exception handling like this. You can write ignore that warnings. So the when you use this one, whatever warnings you get it without disturbance of your execution, then it automatically will do that.
Okay, got it.
Now what I'm saying, that whatever the models, Python library maintain, that it is to maintain the predefined package in the model result, we are maintaining the storing all the models. It is not necessary. It's okay if you execute it, no use. Now coming to the data set, you see that before the line number 4, we will use the Titanic data set which is available in the Kaggle. Data set is downloaded from this path. data set is about the people on Titanic. It contains some attributes and status which is survived or not. Okay.
Okay.
See the requirement, understand again. The Titanic data set, right, people on the Titanic, it contains some attribute and status which is survived or not. Did you get my point?
Okay, yeah. Zero. Yes, yeah. 0 means not survived, 1 means survived.
Yeah, definitely that will convert it, no problem. But your being survived or not is a categorical, right? Survived is 1, maybe not 0. That your wish. But understanding problem, right? My email is a spam or not. Definitely go for classification.
Yeah.
Customer bought the product or not. He done the search in the flipkart.com, but customer bought the product or bought the product or not. Right?
Got it.
So survived or not here is my target variable. So that I can decide, no problem. Now, first of all, can you open this data set, Titanic data set, right? Or else please directly create the data frame. You observe that here. The same thing what I've done last class. We are doing the same thing here. Titanic data is equal to pandas.read_CSV.
Yeah, 1 minute. Let me just import that data. Hold on a second. My directory is different.
No problem. You can give your own path. Where is your Titanic file? Is there? You give the same path. See, that most of these structure files, when you creating data frame, it will come with the column names. That means it come with the schema of your data set.
Right. 1 minute. So yeah, here is my file. I just need to change this thing. Yeah, I got it. Okay.
Data frame created.
So yeah.
And see, check the head of the schema, because whenever you want to see the data frame, just Titanic data underscore dest and enter, but it will not show you column names. But if you want to see the column names, dot header, right? It will display your data frame like this with all column names. Now you need to understand here, very important step for you in the step number 5 to understand the data. See that now totally 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns are there, right? Yeah. There is 12 columns are there, right? In these 12 columns, passenger ID, survived, P class, name, sex, age, flight pass, ticket, fare, cabin, IMA. There is a, right, 4, 5, 8, 10, 12, right? 12 columns. Oh, you observe that passenger ID, okay. Survived 0, 1, okay. The class of passenger, okay. Name of the passenger, okay. The gender of the passenger, okay. Age, okay. Siblings, right? And number of parents and children's, all right. Ticket, fare, right? Cabin, embarked, isn't it? You see that now I clearly given the description of the data set. Compulsory client should give the description of the data set, or else I can't use my own column names, or else I can't give my own data column names, isn't it? So you need to understanding the data is very important. See that now embarked means, you know that, the port of embarkation, Southampton, like Queenstown, Cherbourg, like this. Cabin number, fare of the price, the ticket number, number of parents and children, number of siblings and spouses about the Titanic, age of the passenger. See that now in this data, name is a categoricals, sex is a categoricals, right? See that now there is only 2, 3. It doesn't matter. It's very best good data set for. But what I want to do that, see that now what I'm doing that, I am taking the required features only for my model. See that now I am doing extraction. You observe here now. survived, P class, sex, age, sibling, and number of spouses, number of parent children, embog, fate. So out of 12 columns, I am taking the 8 columns as my required features for my training or my data set. That is, the data frame is the Titanic data.
Yeah. Okay.
Then you can see Titanic dot head, and now you can see the schema column names 3, 6, 7, 8.
Okay. Okay, got it.
Now you see that now dimension of the data shape. Shape is a function. Yeah. Right, shape is showing that 891, 8. So it's like a max and min is there. That doesn't matter. Now you see that now actual target where is what? Survived or not? Survived or not survived? Now you observe in the line number 9, survived it. My data query here on my data frame value underscore count. I want to check that number of people survived, number of people not survived 0, 549, one is a survived 342, isn't it? Counting that. If you want to understand now, you can use a graphical plot. Now you see that Seaborn is a like matplotlib package of visualization. Seaborn also visualization package. Now I'm using the count plot. What is the, I am checking that here x equal to survived data from which data set? Titanic data frame. Got it now? So if you want to understand it graphically, you see that now 0 not survived, 1 is survived. Not survived how many? 549. The bar is very high. 342 bar is low, right?
Okay.
So I want to do prediction accuracy of this, right? Target variable. After trying the model on your actual data set, we'll do the prediction on this, right? One of the tested variable, one of the future of the testing data set that is survived, isn't it? Done?
Okay. Yeah.
Done till now?
Yeah, I am able to reproduce. Yeah.
Okay. Are you following, right?
Yeah.
Now,
Just
before
graph and all
applying
that.
the classification algorithm, we will perform the feature engineering task on the data set, obviously. Because I want to clean a lot of things, I want to do a lot of feature extraction, I want to do handling the numerical values, I want to do the handling the categorical things, I want to do statistics on my data set before applying the classification model on my final data set. Now see that now. First, we will check the any missing values in the data set. Entire data frame, any value of feature is missing. Survived false,
Okay.
right? Class false, sex false. See that age. You observe the age feature. See that in age column. Did you observe the age features? Yeah.
Yeah, 177 null values. Yeah.
Exactly. Right now, observe here. Sibling parts. Embog true. Test fair false. Now you can see counted, right, is with the sum 177 is the null values. Embog. Now you need to more work concentration on age. Now, before going to next step, without seeing next step to 13, please see the line number 12. My question is here, you get any idea, you're getting any right thoughts to remove any feature? You're getting any thoughts to apply the standard deviation? You're getting any thought to apply the median mean? You're getting any thought to apply the correlations? So always think like that when you are going to do the things. Now you're doing very clearly null values are there or not, count the number of values. You're checking very clearly before going to train that. Yes, age is 177 is there. But take in the, if you train the model with the more null values of the future of the age, it is not good practice. Did you understand? 177 values are null means that is not good practice. You need to do something statistical formulas need to apply in the age future, isn't it? You see that the point written here, age is a continuous variable. It contains the 177 null values. You can replace null values by different strategies. Here you can replace null values by mean value of non-values, non-null values. Sir, Ajit, are you following that?
Yes, I got it. Yeah, I'm on mute, but I'm following it.
Mean value of all non-null values of the future. Out of 170 or totally 177 null values are there. Whatever the values are there, that values you can take sum by count as a mean. That mean value you can replace in every null value of age. Isn't it?
Okay. Yes, got it. Yeah.
This is one of the statistics, is a very common these statistics which are using in the regular models of projects. Now see that now, age, right, fill now, this is a function, Titanic data frame, age, mean, in place equal to true, right?
Well, what is that last parameter, in place equal to true?
Like we see the I location, ILOC, like this, you remember, like this in place, the where the future is true, the value of age is true, which has a value.
Okay.
That values you are taking to consider the average, that means mean. Okay, that is storing now at the here automatically storing the values of where in the age futures. It replaces all the true values of the age.
Okay, so that means there we can give any Boolean condition, right? In place equal to true. Like we can give like where age is greater than 50. So consider for mean only those ages that are greater than 50. Something like that.
Exactly. Yes. Most of the times.
Okay. All right. Yeah, got it. Yeah.
Now you can check that now. Now embarked content. Now next feature. Now see the line number 22. One more feature is the null values. Two null values are there. Only two.
Yeah.
But this is not big responsibility. But anyway, embarked two null values are there. Now here some people, without understanding of the problem, without understanding of the data set, they will do a lot of future engineering concept. But some people, even that future is not needed for your train the model. Some people, they will do statistics. So what is, I will tell you to the people, please remove that future, which is not necessary in single percentage of your model training. Then no need to apply statistics. You can, if you don't need the future for your model training, which is not independent variable of, it is not dependent variable of the your right prediction, then no use that to maintain the future. You can remove that also. Okay, we'll see that one later. Here, embark contain two null values. We can drop these two records without impacting much on our algorithm. See that now what I'm saying here? Two null values, okay. We can drop these two records without impacting much on our what are the algorithms you trained that. Now see that now drop now. Previously we are filling now, and you are now drop now. N plus equal true. Right?
Okay.
Clear now, guys?
Yeah, I got it. Yeah.
Now coming to the yes.
So can we print? Can you print the data frame? Oh, yeah. Basically, all the ages will have the average values and two null embarked rows.
Yeah,
will
we'll
be
print
taken
it.
out,
Yeah,
right?
we can do that. Okay, but you all do this practice now, but still now you observe that your actual data set, you selected the columns, your required columns, okay. What are the required column data set you selected? The data frame name is Titanic underscore data, right? But you selected your required columns. But what is this machine learning saying that? What is the data scientist saying that you should split your data set into training and test, right? But you didn't.
Yeah.
You didn't split still now. Then what is the purpose of doing the future engineering, right? After splitting the data set into training set and test data set, then you can apply to right future engineering. You can do statistics. Now that's why. So this is all the practice once you got it. Now what is doing that? Now coming to the very important, right? What is the now line number 16? You see that.
Okay. Yeah. Data X and
Yes.
data Y.
This is the step 4 of the data science algorithm, right? Model steps. See that now step number 4. What we discussed in the last class, right? You are splitting the actual data set into training data set and test data set. Now X Titanic underscore data underscore X equal to is my training data set, which are independent, which are the dependent variables, and what is my target variable, right? Independent variable survived. That is the column name, right? That is the future name. That is the data schema of the right now. Why you see that in my Y data set only one feature I taken as that. Remaining what are the future, right? Out of 8 columns of the data frame, only we taken the 6 columns, 7 columns in the training, and that name is X. Test data set Y. Right? Now my question, you are going to apply the future engineering on X or Y first of all?
On X.
X,
On our
exactly.
test set.
X training data set, sir. X is a training data set. Y is a test data set, sir. Your prediction on the test data set. You are checking the prediction on the test data set, isn't it?
Yeah.
Good point. I learned the guitar last 25 days, then 26th day I will test it about the performance of my learning of last 25 days. Right?
Yeah, got it.
I'm playing guitar good or bad after 26th day. That is my agenda, isn't it? So before 25 days, we will train, learning by who your machine is learning, not me, not the developer, not the data scientist, isn't it?
Yeah.
Now you see that now. Now you can start to apply the future engineering concept on the training data set. Now you see the line number 16, sir. Very important. Line number 16 and line number 17. Now see that. You have to perform more engineering on the data set. Aim of our classification algorithm to create a model that works well on unseen data. So first create the test data set and keep it separate for the testing purpose. This is a very important, sir. Line number 17. X underscore train comma X underscore text comma Y underscore train comma Y underscore text. You see that training data sets X underscore train, X underscore text, Y underscore train, Y. See that now? Divide your data into training and set. Training set, I told you most of the training data is highly high. Training data set will be very bigger than testing data set, isn't it? Because 80% of the data is there, means that's the reason we are applying the future engineering on training data set, isn't it? 80% of the data training data set, 20% is the test data only. That's why very less future extra engineering in the test data set. Most of the time, 80% data of the training data is there. That's the reason we'll do a lot of future engineering, a lot of statistics. Now here you observe that from which data set, Titanic X, Titanic Y, right? See that now, X, right? Test data set is a 20%, 0.20. So when I put the test data 0.20%, this means automatically training data set is a 80%.
Okay. Okay.
Now you see that now. First, X train is my actual training data set. Before checking that X train data set, before doing the diagram you can apply anywhere, bro. To understand the data, instead of seeing the thousands features of the data sets, you plot the diagram to understand yourself. Right? Now see, then again I'm doing here diagrammatically to count the number of P classes. C bond, count plot, X equal to P class from which data set? Training data set, X.
Right.
All right.
Yeah, got it. Got it. Yeah, I can see the graph generating. Yeah.
Done?
Yeah.
Done still now? 17, 18 done?
Yeah. I'm executing it simultaneously.
Okay, now 19. Now what I'm doing that X train. Now very, very important. Now see that now age column, why the graph showing like this. See that now when the graph is showing like this, see that now your data is not quality of a specific feature, that is age. See that now when I can say the future, the values of the future is, the quality of this specific feature is good. When graph moving like this, the values of future, the future of the data maybe is not correct. See that? Can you see in the middle bar line, right?
Yeah.
Now see, the graph is not going like this straight way. It is not going single vertical way. It is taking the different curve taking that. Now what are you saying that? This graph, what do you call that? Histogram.
Yeah.
Right? To check the any feature quality, about the quality of the feature, you can use this histogram diagram. It is giving the very best indication of the quality of your future of your training data set. Now, obviously, because of understanding this curve, I can understand myself the future of age is not good. The quality of age data is not good. Why? Because
No, yeah, we cleared all the null values, right? Then why it is complaining that it is
no,
not?
sir. You didn't clear it, right? You observed the X train. Did you apply that? Do you see the X train you just created in the line number 17, right?
Yeah, by clear clean we filled it with average mean.
You didn't
values,
fill it,
right?
sir. You didn't fill it still now. Please check it. X underscore train enter. We didn't apply. We didn't see that. Line number 17, see Ajit. Ajit, you given just data. Come on, yeah. We given, right? That is, you done before dividing the training data test data. We done some practice for you, isn't it? Got it now? The actual data set Titanic underscore data, which is split with the train to X test, isn't it?
Oh, okay. Sorry. Yeah.
Now you see that age future is a very bad quality of data. You see the graph.
Yeah.
It is showing that, right? It is all values, almost 177 values of the age field is nulls, right?
Yeah.
So distribution is nothing but the age of the data. It is very bad quality. How can I understand graphically? There is a best diagram for you, histogram, right? The peak is giving very bad peak of this thing. So that's why we are replacing with the mean values that we done it. But on actual training data, we didn't do that. So which is due to replacing missing value with the C bond is plot X train age. Now, all right. Now like this, I'm checking everything now before doing that. Now I'm applying fair also. Now see the fair is better. Fair is very, very better than age, right? The peak is going very nicely. See that is better, not bad. Because I think values of fair is almost filled it with values, not null values. I think there is a zero null values in the fair. So now what
Okay.
is your challenging here? You should apply the status until the age future values should be like fair future. If you want the quality of data like fair future, you should do some. You should apply some statistics on age future, isn't it? Are you getting my point?
Yeah.
You
Yes,
know
yes,
point.
got it.
Then only your model give the
Yeah.
good performance and the accuracy prediction will be better than, right? Clear now?
Yeah.
Now you see again 21. You see 21, what I'm doing that.
Standard scalar. Okay.
Z-score, standard scalar, nothing but is Z-score normalization. You remember last, just we done today.
Yeah.
Z-score
Yeah,
normalization.
yeah, yeah.
So what is the use of Z-score normalization? I told you, because data is now almost filling with the null values. I want to take the future values in between 0 to 1, because we're machine learning understanding 0 to 1. So maybe I can apply the, you can ask the question, I can take the mean or I can take Z-score, which is the better? Suppose your age, the values of age future is a very, quality of the data of age is very bad. Now a data scientist will write the question like this. Sir, I want to go for Z-score normalization to replace all the null values of age, or else I need to use the mean formula to replace all the values, all the null values with the average value. So which is the best option for you as the best data scientist?
I think Z-score, yeah.
Very good, Z-score. Why? Because Z-score is giving always in between 0 to 1 only, right?
Yeah.
But average is giving definitely 1 point, 3 point, 10 point, 40 point, we'll get it like this, right? Again, that, that long length of data is a high dimension. So obviously, the person is doing that, is good experience guy, is always going for Z-score normalization. Yes, he can do with a mean also, not a problem. But you can see the accuracy of the prediction with the mean value of age. You can check the prediction of the accuracy of the with the Z-score normalization of the age value. It is little difference. But end of the end of the project, what is expecting by data scientist, best data scientist? He want his model high performance with the best prediction. That is the end of the agenda, right? End of the project target, isn't it?
Yeah.
Clear now?
Yeah. Got it.
Now I apply the Z-score normalization. That now leave it that one. Now, before seeing this normalization, first your main focus. Now first check that x underscore train dot head. Come to line number 25.
Yeah. Okay.
There is only 6 columns are there. You observe here. Because you split it into training data set. Did you find the very dependent variable in the line number 25, Ajit?
No survived
Because
column.
we divided your main data set into training data set and test data set, where training data set has independent variables, which are the input features, which are the input label to train the model, isn't it? Right? Actually,
Yeah.
your data set has a your data set has a 8 features are there. But once divided into train and test data set, they were trained as only 7 features, which is your main train data set. But I need to start to apply now. You see that now x underscore train head age is replaced with all right Z-score normalization, and fair is applied with the normalization. See that now I take in the normalization on the age on fair. Now you understand the question now. Can you check the fair? Why I taken? You need to ask the question. Ajit, the fair is why I am taking the normalization, because the values of fair is a 425, $4,000, $5,000. It's a very high integer value, right?
Correct. Yeah, absolutely.
That's the reason
You
I
have to
apply
bring
the
all values.
yes. Before this, I told you in the starting of today's class, when your salaries, when your employee IDs are there, you can best option go for the normalization to minimize your dimension of the future That is the best practice for the best data scientist. That's why fair and age I take in with the normalization, take the data between the 0 to 1, because where machine learning is understanding zeros 1. Now see that now. Now here, now your data frame is perfectly ready for train the model with the line number 25.
Yeah.
No. One more feature, you see the sex. Sex is the categoricals.
Oh, yeah. You need to apply the label factor. Yeah.
Exactly. 0, 1. Male, female 0. Male. Got it now?
Yeah, got it. Yeah. Its label encoder is marked on embarked and not on sex, huh?
Yes, embarked only, not
Oh,
sex.
Okay, cool. Got it.
Because embarked also, you observe that. Because embarked South Station and North Station, different names are there, right? Right? So that is purely big categoricals, isn't it? So machine learning is instead of taking like that, right? South Station, North Station, California Station, like this, instead of all these things, you can take the embarked. I take the feature of the embarked is the encoder, isn't it?
Yeah.
Now you see that when I apply the label encoder, now you can see that whatever my embarked features next train, right, with the embarked with that, right, S, 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 Q, S, 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 we got it like that. So instead of big category of strings, right, we take the string single character wise embarked it is a better that. Now you observe that line number 29.
29, okay.
Correlation, now you got it. Last class we done correlation. Now, correlation. You see that now P class, sex, age, siblings, member of parent children, embarked, pair. See that now the correlation will happen between the every feature of the entire data frame. P class with the sex, sex with the age, age with the siblings, siblings with the number of parent children, number of parent children with embarked, and embarked with the fair. Isn't it? It do the correlation for the entire trained data set. Right now, see that now the correlation of the every feature is very, very perfect for that. So, which is a highly correlation. Now, you see the diagrammatically here, P class sex, right? See that now we value 0.04. So, there is no any big correlation between them because a lot of difference is there. Now, you see the age. I given the formula last class, correlation formula.
Yeah.
Take the two feature values and do that correlation. Now you see that now age and number of siblings 0.4 and 0.00. There is no any big correlation, right? There is a lot of differences there. Now, number of siblings and number of parent, maybe it is good correlation, maybe. Is okay, little 0.02 means 0. Minus 0.4 means it is little near, right? Hello?
Okay. Yeah, I'm listening. Yeah.
Now, next, very, very clear, good correlation between the two things here. Minus 0.4 to 0.8, that is number of parents and with the number of embarked, right? Isn't it? The parents and children and embarked. It is a good correlation, right? And the fair is, that is 0, minus 0.8, and right? So here, fair to fair with embarked, embarked with the parents, parents with the siblings, isn't it?
Yeah. Okay.
You're checking the correlation, that's it. Now, what is the purpose? I told you last class, correlation. Why you are checking the correlation of the feature and what is used for my, as a data scientist, what is used for my model? I told you very clear point as to last class. Did you remember the point? Can you remind that point? Can you recap that point? What is use of
Can you ask
correlation?
the question?
What is used to check the correlation of your trained data set? What is use of correlation?
Yeah, I mean, how close are two different values to each other?
Exactly. Now, yes, what the correlation is useful for that, because according to your target variable, that futures are useful for that, which is correlated for your prediction or not, right? To can check now. Obviously here, fair pay class, we see the fair pay class is a high correlation, right? In right here, in here you're doing your classification. So what I'm saying that when data is with a high correlation, you can take the any one feature. Suppose age and example gender is there, bro. These two which are high correlated. So you can take any one feature to consider to train the model, but don't take the two features which are high correlated for to train the model. Then it will affect the performance of the model.
Yeah, then it's like always true. Yeah, correct.
Okay.
Okay.
Now our data is ready for machine learning algorithm, which is my right x train original equal to x train dot values, y train dot values, right? So the original x train is a main train, right? Train data set, y train data set, both are same, bro. Don't confuse. You can train because we done a lot of statistics x train, so you need to train the model with x train. Okay.
Yeah.
Now, what is the agenda here? Requirement survived or not? You observe that survived, you take in that. What is the values of the survived? Can you come back? What is the values of survived?
0, 1. 0, 1.
Target value 0, 1. So it is numerical, right? Now I am observing that when I take in the target category numerical, I am using that. See that now, 32. You are not writing 100 lines, 1000 lines of programming. Simply your Python already inbuilt libraries of all the models. Just create the object of the model. See that now, this is already inbuilt in the Python, which is highlighted here. Can you see my screen?
Yeah.
Which is highlighted, which is already inbuilt in that. So, but we are creating the object because to train the model with my data, my trained data set, isn't it? Now logistic regression is my model is ready now. My model, I need to train the model. I need to learn the guitar with my required inputs. So your machine learning model logistic regression dot fit x train y train. Are you getting my point? I am training the model. X train is which is 7 features, which is all numericals, which is all clean, which is done statistics, which is perfect ready. So that's why I told you here is a line number 30. You see the line. Now our data is ready to apply the machine learning classification algorithm. Right, we are applying the right one of the algorithm of the supervised learning logistic regression, which is dealing with the numerical target variables. So I trained the model. Now I trained the model. The model object is that logistic regression. Right? Hello? Hello? Hello?
Yeah.
Yes, Sajid, can you hear me?
Yeah, got it. Yeah. There's a lot of disturbance in the voice, but it's okay.
Okay. Right. So, okay, till today, okay, this one. And tomorrow, this model, whatever trained model, will test on the your test data set that is survived, and we can see that your accuracy of prediction. Okay?
Okay.
So, if you have time, you can go for further practice this one, and we'll see tomorrow. We apply logistic, we'll apply the classification, we'll apply the all models on this data set, bro, which is giving the best accuracy. Okay. That model you can decide to deploy it into server, isn't it?
Yeah. In the meantime, I will just practice all this for tomorrow.
Okay. Thank you. See you tomorrow.
Okay, thank you, sir. Have a nice day.
Thank you. I think you tried, huh?
No. Actually, main problem is I'm not able. There's a lot of audio quality is not very good. So you blur a lot in between. So I'm not able to catch up.
Really, my side is very good, yeah.
Yeah. So no, but whatever you said, I understood.
Okay.
But I think describing the model, the audio should be very clear. So let's do it tomorrow.
Okay. So tomorrow we'll complete this. and we'll do a lot of hands-on.
Yeah.
Okay, thank you.
Okay, bye.
Thank you, sir. Bye.